Do you have anything to ask from previous lectures? Nothing? Then let's continue our discussion on this ray optics, and this is lecture number 8. And we were discussing, I think, refraction. Did I start off with sheet number 3? I started. How many questions have I done from sheet? 6 questions done on the board? Great. Then go for question number 7. Let me give you 2 minutes to think about it, and then I will do it afterwards. I will start at 12:10. Is it visible to everyone? Go for question number 8. Do it quietly. How many of you are done with question number 7? Okay. Let me attempt it. So this is sheet 3. Sheet 3. In question number 7, it's saying a ray of light traveling in a medium of refractive index mu is incident at an angle I on a composite transparent medium. So a composite ka meaning, do you understand? There are so many layers in between the two layers that we care about, the two boundaries. So this is sheet 3, question number 7. You have a medium of refractive index mu. The ray is incident at some angle I. In between these layers, there are so many in between layers. It's a composite medium. And afterwards, what happens is, it comes out, it emerges, makes some angle x. What is the refractive index of this medium, the final medium? mu4. Then they are asking to find a relation between this incident angle I and this angle x. Then what can I apply here? I can apply Snell's law between these two mediums. Then what will Snell's law read? It's something like mu sin I is equal to mu4 sin x. Then what will be sin x? Mu by mu4. So simple. You don't have to care about how many mediums are in between. You don't have to care about that. Take one boundary, take another boundary, apply Snell's law. Okay? Let me ask you this. If there were to be some kind of boundary here and you had an angle y, let's say there was a mu 0 here, can I apply Snell's law on this and this? I can. Can I apply Snell's law on this and this as well? I can always. Do you understand? Whenever there is a refraction, I can apply Snell's law. Is it okay? If this question is done, then go for question number 8. All of these are very simple hand-picked questions. question number 8. I will give you 2 minutes again, then I will start. Fairly simple questions. एक मिनट में हो जाएगा. Anybody done with question number 8? What is the question number 8? What is the answer that you are getting? Incorrect. This 8th one, again a fairly simple question, a little tricky. Option? Yeah, well, mathematical. Mathematically are right. Should I start off with the question? A is correct. Okay then, I think the question number 8 is something like this. In the question number 8, it is mentioned that you have an XZ plane, and the XZ plane acts like a boundary between the two mediums. It's separating two mediums, mu1 and mu2 are the refractive indices. So let me make the coordinate axis something like this: x, y, z. And can you imagine this XZ plane is a boundary. So let me make it much more better. नहीं अच्छा नहीं लग रहा है. Can you imagine this is a XZ plane? This is my XZ plane. This separates two medium. Jayesh, come and sit there. You have a refractive index mu1 and a refractive index mu2. I think the incident ray direction is mentioned. What is that given to be? It's given by a unit vector, na? It's given to be I cap is k I cap plus b j cap. This is your RA vector as mentioned. Then you have a refracted ray direction by some unit vector again. What is that given to be? That is given to r cap as alpha I cap plus beta j cap. Yes. Now they are asking to find a relation between mu1 and mu2. Then how will you find a relation? Again Snell's law. Every time you apply Snell's law. So पहले बताओ ये when the ray comes, the ray will hit like this. This y-axis will act like a normal. Can you imagine this is the XZ plane, y-axis is coming out? Yes. So What is the angle that you are making here? That's the incident angle, right? Incident angle. And if you complete this triangle, then can you tell me the x component of this vector? Look at it. That's A. This is A. What about the y component of this vector? That's B. Then what will be this hypotenuse? It's under root of A square plus B square. Is it clear to everyone? And what is the length of a unit vector? 1. So what it should be equal to? This represents the length of the vector, na? This is 1. Then can you look into this triangle and tell me what is sin I? Sin I is equal to A by 1, which is basically AB. Right? Then let me apply the Snell's law and tell me what should I write. So by Snell's law you get mu1 sin I is equal to mu2 sin R. But what is sin I? A. Can you predict what should be sin R? Let me not do the calculation. It should be alpha, right? It should multiply by alpha. So mu1 into A is equal to mu2 into alpha. This is the relation. Yes? Did you understand? You just have to make a triangle. Imagine in 3D and then try to make a triangle. Are you understanding? DD समझ में आ रहा है? ये ऐसे सोचो, ये y एक्सिस है, ये x, ये z, ये प्लेन है, ये प्लेन है हमारा जो दो मीडियम को सेपरेट किया। अब एक रे है इसके ऐसे एक्टिवेट कर रही है, अंदर जा रही है, वो मैं दिखा नहीं सकता हूँ, ऐसे आएगी। वो इंसिडेंट रे का यूनिट वेक्टर से डायरेक्शन दिया हुआ है, देखो इंसिडेंट रे that is given to be ai cap plus bj cap. तो जब वेक्टर ऐसा है, तो इसमें मैं दो जोड़ सकता हूँ, x कंपोनेंट y कंपोनेंट। ये वाला जो रहेगा वो y रहेगा, ये वाला जो रहेगा वो x रहेगा। वही दिखता है। और उसके बाद होता है हाइपोटेन्यूस और वो 1 रहेगा क्योंकि वो यूनिट वेक्टर है। तो उसमें साइन निकाल, ऐसे साइन r भी निकाल। If you are done with this, then go for question number 9. By the way, in question number 9, please change the option number D as multiply by 2. Make it 2 cos inverse. And then tell me the answer.
Is it option D?
Option D. Option B, Bombay. Incorrect. Should I upload the sheets, by the way? I have not uploaded inside the description of the YouTube channel videos. Should I upload the sheets as well? I don't, because you have the sheets. So when you look at the video, you can look at the sheets that you already have. ये कर दे upload description में. I don't even know if a single person watches from here or not. but still I put this so that I don't have the headache afterwards. If you miss a lecture, just look into the video. Should I start with question number 9 then? Okay. I will wait 1 more minute. I will wait. 12:24. Option? Correct. You got the answers? And let me try the question then. Question number 9. What is it asking? You are asked to find the angle of incidence and some information about this. I and R is given. Na? What is the relation between I and R given? I is equal to 2R given. Also they are said ki mu1 is air. So what will that be? 1. Refractive index of air is 1. What about the second medium? Root 2n. This is what they have given. And the diagram can be thought of like this. ये I, ये R, ये mu1, this is mu2. Good. Now they are asking to find the angle of incidence. Then can you do it? Again, the same formula. Na? Every time I am using the same formula. mu1 sin I is equal to mu2 sin R. So here mu1 is 1, sin I is what? Let it be. Achha, sin I can be written as 2R. Na? So let me write it like that. So root 2n sin R. This is sin 2 theta. What is the formula of sin 2 theta? 2 sin theta cos theta. So ये sin to गया. Then I think you will get cos R. What is the cos R value? Cos R is equal to root n by 2. Then R is equal to root n. Cos inverse of root n by 2. If you get R, can you find I? It's just twice of that. Na? So I is equal to 2 cos inverse root n by 2. Good. Fairly simple question. These are all simple questions. You don't have to think much here. Now that we are done with this, let me go to a new module now, a new topic. So let's go to the topic of refraction from a plane surface. The single refraction from a plane surface. Okay. And here we will mainly be talking about apparent height or apparent depth. So, have you ever seen this key when you're fishing or anything? Have you seen here? Or maybe you are inside a swimming pool, something is kept on the bottom of the floor, but then it doesn't feel like that it is there, rather it feels like it's somewhat elevated. Na? Have you ever experienced this? Yes? What you see is not the actual position of the object. Yes or no? So what is the height or what is the apparent thing that you see that we will try to find? Okay? That's called apparent depth. And we will take many cases here and consider all the things. So the topic is apparent depth. I will do the derivation for everything for case 1 and then we will try to find the formulas for case 2, 3 and 4 intuitively. ठीक है? पहले case 1 की बात करते हैं. Case 1. The case 1 is something like this, that you have two mediums. You can consider this to be water, this to be air. There is an object placed here, and you are looking into the object. Just what I mentioned right now. You are looking into an object which is placed inside the water body. You are looking from here. Good. And always remember, I am about to write something. Always remember that whatever medium has the object placed in it, I will consider that to be mu1. Always, okay? It's not necessary, but it will be convenient for all the formulas that I derive. So I will write here as mu1. What about here? Mu2. From here the rays will come out. They will suffer some kind of refraction. But बताओ कि mu2 is greater than mu1 or mu1 greater than mu2? mu1 is greater than mu2 ना? This is water, this is air. So where will it bend? Away from. ये मैं थोड़ा I को shift कर देता हूँ. Where it comes out like this. This is my end. If I retrace this ray backwards, then what will I find? I will find something here. What will that point be called? Can somebody tell me? What is this point called? Apparent object. From where the rays appear to diverge? Huh? Virtual image. The rays appear to diverge from virtual image. The rays appear to converge at virtual object. है ना? The rays actually converge at real image. The rays actually diverge from a real object. ये सब definition क्या नहीं है? So I will write it as I prime. Is it okay? What should be these angles? Can somebody tell me that? So let me make. ये angle बता सकते हैं? ये angle को what should I write? That's angle I. What about this angle? That's angle I. What will be this angle? What will? ये angle आप ये angle कितना? ये भी आप ना? तो ये एक line है ना? So what is this angle? Is that okay with you? Good. Is it visible to people in the back? Now look into this. I'm going to make this triangle and this triangle. So let me magnify that. That's one triangle. That's another triangle. What are the angles? This is angle I. This is angle R. This is I prime. This is O. Let me give some other names. A, B, C. Why am I writing all of this? I will eventually use Snell's law. Somewhere I will use Snell's law. Snell's law में sin I, sin R आता है? Can I find sin I and sin R from this triangle? Yes? Can you tell me what is sin I from this triangle? So, yes. Sin I is what?
OC by A.
OC by
A.
OA. OC by OA. Yes or no? What is sin R?
I dash B.
I dash B by I dash A. Is it all okay? By the way, this I dash B and OC are equal? Yes or no? They are equal, right? So if I take the ratio sin I by sin R, what will I get then? Sin I is what? OC by OA upon I prime B by I prime A. What can I cancel here?
OC and
ये cancel हो गया. Then what will I get? I think I will get I prime A over OA. What is I prime A? This is this distance, sir. This is where the image is formed. This is the point at which the refraction or everything is happening. Then what is this distance called? The distance at which the image is formed. What is that called? Image distance. Very good. Wow. That's called image distance. So I should write it as V. What is OA called? Object distance. That's U. So what is the relation between object distance and image distance here? E is equal to sin I by sin R into U. Can you tell me by Snell's law? I can write it in terms of mu as well now. Can you tell me by Snell's law what should be the relation? Apply Snell's law and tell me what should be the relation between mu and sin. बता इसका oral नहीं बताओ. So it should be mu1 sin I is equal to mu2 sin R. Is it all correct? Then what is sin I by sin R? mu2 by mu1. Then what should I write? V is equal to mu2 by mu1 into u. This is the relation between the object distance and the image distance when you have a plane surface like this which is separating two medias in refraction. It's not so simple as. By the way, can you look into this? When you had a plane mirror, if you remember, then what was the relation between object and image distance? B equal to minus u. There was a negative sign, na? Negative sign represents what? If you have an object here, then the image is here. Do you have a negative sign here? No. If I have an object here, then the image is placed at the same direction. Yes or no? Very important. Yes? And please don't get confused between 2 and 1. Bonds are 2 and 1. What is 1 considered to be? That medium which has the object. Yes? Good. Do you have any problems here? I did not find the apparent depth, so let me try to do that. So, by the way, under paraxial approximation, do you remember what was paraxial approximation? The rays are making very small angles. Then sine theta is approximately what? And tan theta is approximately? 1. Sine theta is theta, tan theta is theta, cos theta is 1. Idiots said something about it. So sin I can be approximated to tan I? Yes? Can you look into the triangle and tell me what is tan theta? Tan I is what? What is tan I?
OC by AC.
OC by AC. पक्का है क्या? नहीं बेटे, अच्छा OC by AC का. What will be tan R? I prime B by AB, I think. And if I take the ratio again, then what will I get? Sin I by sin R will give me what? Sin I is what? OC by AC upon I prime B by IAB. Can I cancel something? I think I can cancel this, and then what will I get? AB or no, AC is sin I by sin R into AB. What was sin I by sin R equal to? Mu 2 by mu 1. So this will, what is AC by the way? If you look into this,
Depth
what
of
is-
the object.
yes, AC is the depth of the object, right?
Yes.
What is AB equal to? That's apparent depth. Always remember that the image ka depth is the apparent depth. Object is the thing that is real to us. Yes? What is happening?
It's not focusing.
Anyways, so what is AC equal to? That's mu 2 by mu 1 or D apparent is mu 2 by mu 1. Always remember D is the depth of the object. D is what? Depth of object. Did I say real or virtual? No. Then in general object. Okay? Are you okay with all of this? It's very simple, na? You pick two triangles, apply tan, apply sine. You will get it. Let me also tell you this. If I assume that the upper medium is air and the lower medium is some refractive index mu, then what can I write here? If you have the result that upper medium is mu 2, as mu 2 is equal to 1 and mu 1 is equal to mu, then what can I write here? Can somebody? D apparent is what?
D by mu.
That's D by mu. Very important. Yes. So in the case 1 where the object is placed inside the water and you are looking from above, you find that, so D by mu is in general greater than 1. Na? I gave you a case where mu was less than 1 as well, but in most of the times when we are studying here, we will be considering greater than 1. Okay? If mu is greater than 1, then D apparent is less than D. Yes? And this is what we found from diagram as well now. Does it make sense to you? Great. Write this and then I will discuss case 2 and 3. घर चले जाओ बेटा ठीक है इतना पैसा लेके बैठने का फायदा क्या है सुन लो घर जाके Are you done writing? Can I go for case 2? See, even if you don't remember the derivation, it's all okay. The final stuff is the thing that you have to remember. But the logic will be understood only after derivation. Is it done? Okay then, case number 2. Triangles नहीं बने अभी तक. Okay. Case 2. Now I will not derive anything. Now I will just find the thing intuitively. Okay? We placed the object inside the water before and we were looking at it from above. It could be thought of as a fish. You are looking at a fish. Now imagine you are inside the water and now you are looking at an object which is in the sky. And what can that object be considered as? Maybe a bird. You are inside the water and you are looking into a bird. क्या फिर से अनफोकस कर दिया करो उसको सही you have two mediums here and now let's say the object is placed here the object is placed here and which should I consider mu1 and which should I consider mu2? mu1 is the above one, mu2 is this one. Then how will it go like? क्या हो रहा है? क्या हो रहा है इधर? The rays will come out like this. Will it bend towards the normal or away from the normal? Towards the normal. So कैसा होने वाला है? ऐसा होगा. And if I extend the rays backwards, then I will find an image here. What will be the nature of this image? It's a virtual image. Just say it like that. It's a virtual image. I dash. And this is where my person is viewing. So, is it all okay? Please make straight like that. My drawing is not that good. Should I make it again? देख रहा है ये straight line. ये straight line. This is supposed to be a straight line. This is a refracted ray. Can you imagine now In the previous case, if you look at it, what was D apparent? D apparent was obviously smaller than D, na? Yes? Your object was here, then your image was found here. Then we divided by mu. Now your D apparent, what does it look like? Is it greater than D? Please look at it. This is my D, and this is supposed to be my D apparent. Greater than or lesser than? D apparent is greater than D. So should I multiply by mu or should I divide by mu? Multiply by mu. Does it make sense to you? So D apparent is mu times D. And if I write in general, then what should I write? Batao? In general, this was the expression, and from here we found these. Based on this, can I be found in terms of mu1, mu2? In general, I should write mu1 by mu2. Batao. Should be what? Mu2 by mu1, right? Because mu2 is considered to be mu and this is considered to be 1. Yes? And you will get the relation backwards here. Is there any problem with this? Is there any problem with this? Initially your apparent height was smaller than your actual height, that's why we divided by mu. This is how you can remember it. Now your apparent height is greater than your D, so we multiplied by mu. And if I consider this to be air, this to be water, then this is taken to be 1, this is taken to be mu. So if I take mu1 as 1 and mu2 as mu, then I get this back. Yes or no? So I'm just cyclically taking. Can I write the case 3? I put my real object inside the water once, then I put my real object in the air once. Now let me put my virtual object inside the water and virtual object above the water. So let's try to find those forces. What will I get here? Let me also tell you this, if you are not convinced that this should be the formula, you can make the triangles and always find it out. And also remember, in the previous case, what was the medium 1? Water. This time 2 is the water. वो change कर रहा हूँ मैं, समझ आ रहा है ना? You keep on changing. Case 3. Case 3 is a case where you have mu1 and mu2. I am putting a virtual object inside the water now. Virtual object का definition क्या था पहले? Appears to diverge, converge. तो rays ऐसी आ रही है, ठीक है? They are coming from somewhere, and if you consider like this, then they appear to converge at this point O dash. But do they go like that? They don't. They refract. है ना? Refract. अच्छा, if this is considered to be mu1 and this is mu2, then what is the condition between mu1 and mu2? mu2 is less than mu1, ना? तो बताओ, ये rays bend away from the normal or towards the normal? When the ray comes like here, the normals, away from normal or towards the normal? Towards the normal. अरे भाई कोई conclusive answer दो. Towards the normal पक्का है? Because it's going to a denser medium. So that means goes like this. है ना? Shifted to this. Then you meet here. And you form a real image. है ना? Can you guess now what is D and D apparent? So this is D obviously. And this is D apparent. What is the relation between D apparent and D? Greater than D. So should I multiply or divide? Multiply. Do you understand what I am doing? D apparent is equal to mu times D. And what should I write in general? In this case, in In general, what should I write? पहले mu2 by mu1 लिख रहा था, अब क्या लिखना चाहिए बताओ? Yes? Take a moment's break and then tell me. It's very simple. Mu2 is considered to be 1 because that's air. This is considered to be mu, that's water. So should I write mu2 by mu1 or mu1 by mu2? Mu1 by mu2. Very good. So D apparent is mu1 by mu2 now. You don't have to remember any of it. Okay? Make a ray diagram, you will understand all of it very intuitively yourself. Which one is greater, which one is lesser, where the apparent depth is greater or lesser. All these things will be very simply understood. These are formulas that I just have to give you. Case 4. Case 4 क्या होगा? I put my virtual object inside the water. Now let me put my virtual object above the water. And that will complete all the cases. So, case 4. What will that look like? तो ये दो है. यहाँ पे कहीं virtual object है. Virtual object इधर है. O dash. तो इसका मतलब है rays were coming like this. They appear to converge at that point. Which one should be considered 1 and 2 by the way? This time? This is 1. This is 2. Which one is greater? 2 is greater than 1. Up when it refracts, then will it refract away from normal or towards the normal? Away from the normal. तो ऐसे या ऐसे? ऐसे ना? Meets here. अब बताओ what is the relation between D apparent and D?
Less than D.
It's less than D. So should I divide by mu or should I multiply by mu? Divide by mu. Very simple. D apparent is D by mu. ये समझ आ रहा है क्या? बहुत simple है cases. It's not that hard. And can you tell me in general then what should I write? D apparent is what?
mu2 by
mu2 by mu1.
No, mu1.
mu1 by mu2. That's correct. So if you look into this very carefully, अच्छा let it. Is it all good? Did you understand all the 4 cases? Did you understand all the 4 cases? There were 2 cases of real object and then 2 cases of virtual object. And did you see that for every time you take a real object, you are finding a virtual image, never a real image. Okay? And if you take a virtual object, you are finding a real image every time. Sort of like a mirror. If you are done with this, then let me give you one note and then you can start with sheet number 4. There's only one note which I have to discuss. Let's say you have a beaker and this beaker contains 3 immiscible liquids. You understand the meaning of immiscible? Not okay? So you have 3 immiscible liquids with different refractive indices mu1, mu2, mu3, and this depth is given d1, d2, d3. And let's say you place a coin at the bottom of it and then you are looking from here. You are looking from here. How will that coin look like to you? What will be the apparent depth? And the formula is, I am not going to derive it, I am just going to give it directly. The formula is D apparent is d1 by mu1, d2 by mu2, d3 by mu. This is the formula that you have to remember. If you have three immiscible liquids and a coin is placed at the bottom of it, and if you are looking from there, then this is the apparent temperature you see. Once you have written this, you can start with sheet number 1 के questions. Sheet number 4 के questions. Virtual object is the point at which the ray appears to be moving. तो ये इसके directions बना दीजिए. They are appearing to light, but then they refract at this point. So this is rarer medium, this is denser medium, rarer medium, and so this is the point at which they actually. No, you see it here. That's a real image. देखते क्या हैं? लॉजिक थोड़े ना देखते हैं. इमेज देखते हैं हमेशा. आप चलो. Question number 1 का figure. Is it done right? Are you done writing? So, sheet 4, question number 1, and the figure is something like this. How many times it got unfocused? What time? बहुत देर तक हुआ था.
That was easy.
Attempt the question number 1. Attempt the question. I'm giving you 3 minutes, then I will discuss. It's asked that you have two boundaries separating three mediums, and there will be a refraction from the first boundary that will create one image, that will be the first image. Now they are asking to find the position of the second image. So try to do that. Position of the second image. That AB is a plane which is separating two mediums. The same is with CD. I will wait till 116 and then I will start.
So 40 by 3.
From where? With respect to what? With respect to surface AB, with respect to surface CD, or with respect to O?
So 27.5.
With respect to surface CD, you are getting 40 by 3. Incorrect.
So 65 by 3.
Incorrect.
27.5 with respect to
27.5. Incorrect. Should I start with the question then? Okay. It's very simple to understand that it will suffer two refractions. Huh? So from the first refraction there will be one image that will be formed. So पहले ये बताओ कि will it refract away from normal or towards the normal? Away.
no, towards
Towards the normal. Huh? Goes like this. Then if you extend it back, then you get a I1 here. This will be my virtual image with respect to surface AB. This ray goes forward and then it refracts again. How will it refract again? Towards the normal again, because mu3 is denser. And if I take it backwards, this is where it will be. How can I find my I2? I2 is my image, na? This is my image, the actual image, the real image. For that, I1 will act like a virtual object. Yes or no?
Yes.
O will act like a real object, create a virtual image I1. That I1 will act like a virtual object, create a real image I2. Yes or no? So first I have to find what is the position of I1, and then I will be able to do the questions. So do you remember that if you have refractions, then what was the formula of image distance, object distance relation? What is the relation between image distance and object distance? V is equal to minus कहाँ से आ गया? अरे it's something like V equal to mu2 by mu1 into U. I just discussed it 10-15 minutes back. V is equal to Mu 2 by mu 1 into u, na? Does it make sense? I should take this as 1. Why? Because my object is placed here. That's why. Yes? So this formula is okay. So can I find, let me write it as V1. That is the image 1 ka distance. Then what is U? Can somebody tell me? Acha, from which surface the refraction is occurring? AB. Then with respect to this surface, what should be my object distance? It should be 10. Let's take modulus. It should be 10. What is mu 2? 1.5 divided by 1 into 10 centimeter. This will give me 15 centimeter. 15 centimeter with respect to AB. So this should be 15 centimeter. Where is my second refraction occurring? CD. For CD, I should assume I1 as an object, na? And create the image I2. I should apply the formula again. But now what will be my object distance now?
25.
It should be 25. Is it all okay with everyone?
Yes.
Because I have to consider with respect to this surface now. Yes or no? Should I write mu 2 by mu 1 again here? What should I write? Let me write the formula. What should I write for V2? What is V2 is equal to? Batao. Should I write mu 2 by mu 3? Should I write mu 1 by mu 3? Mu 3 by
mu 1.
It should be mu 3 by mu 2 ना? Because ये surface पे इन दोनों के बीच में हो रहा है refraction. But where is the ray coming here? Coming like this, right? Do you remember how we found these relations? We applied Snell's law at boundaries. When I apply Snell's law, तो ये ray के लिए ये वाला मीनिंग है ना? So I should apply mu 3 by mu 2. Be mu 3 by mu 2. Do you get the logic of why it should be mu 3 by mu 2 and why it should be 25 centimeter? Good. Then we are done. What is mu 3? 2 divided by 1.5 into 25. Whatever is this given? So 50 into 3. 2 by 3. This will be 100 by 3 centimeter. With respect to what? I got 100 by 3, but with respect to CD. So this is 100 by 3 with respect to CD. If I were to find with respect to O, if in the question they are asking with respect to O, what should be with respect to O? It should be 100 by 3 minus 20. What will that give me? 40 by 3. Yes. Simple question. So I won't be discussing anything more than this for today, since most of the time was wasted away. So I will discuss more questions in the next lecture. From now onwards, I will maybe make a drive, and on that drive, I will upload all the sheets. Okay, so that in the description box you can see the thing, and if you want to go there. Okay. If you're done with this, then yeah, take the break. इसको switch off करना है.